Okay guys, I'm back. And now we're going to spend the time going through and working through the examples here. Because it's a little bit more difficult to do that in the lecture setting. So our examples here, we're going to start with the first one. It says, what amount of work is done when 15 liters of gas is expanded to 25 liters at 2.4 atmospheres of pressure? So we got some information here. They're asking us for the work. They've given us an initial volume, and that's where VI comes in. That's 15 liters. There's a V final. Now that's where the F comes in, and that's 25 liters. We have a pressure of 2.4 atmosphere. So they're asking us how much work is being done. Well, the work is the pressure times the change in volume. Now that doesn't sound too hard, does it? No, that's an easy one, okay? So with that, let's take a look. Pressure, I've got 2.4, okay, multiplied by our delta V. So that, now what is our delta V? It's V final minus V initial. So that's going to be 25 minus 15. So this is our pressure. This is our delta V. Okay? So when we do the math, and notice I'm switching to another color, so we'll have 2.4, and that was atmosphere, right? That was atmosphere, whoops. Multiplied by 25 minus 15 is 10. That would be 10 liters. Okay? So I'm showing you step by step how to do this. Now for some people they may be saying, come on, this is easy. When you learn how to do more complicated problems, it's good to show your steps. Okay? AP Chem is a very mathy course. Of all the 3 AP sciences we have here at Western Christian High School, AP Chem has got the most math. And, as I say, A-Push is a vacation because it doesn't have the math. I'm just saying. Just saying. And some people are asking, is he for real? Yes, I am real. If you can't handle the salt, maybe you ought to think about picking another occupation. All right, guys, let's move on. So we got 2.4 atmosphere times 10 liter. We multiply that out. That's going to get us 24 liter atmosphere. So that's our answer. 24 liter atmosphere. And that was right-handed. Pay attention, boys and girls. Okay, we're going to switch to the next problem. Okay? And I'm going to, before I get there, I want to go ahead and do this. All right? So we already have this. We've already looked at this. Now it says if 2.36 joules of heat are absorbed by the gas above, what is the change in energy? Well, yeah, there's a change in energy, and I said that the hint here is delta E. Remember, delta E is our change in energy, right? And that's going to equal Q plus W. Now, let's go over to here. And we have 2.36 joules absorbed. Guess what, guys? That's our Q. That's our Q. Why? Because it's the heat. It is 2.36 joules have been absorbed. Now we're looking at what's the change in energy. Well, E is equal to Q plus W. We said that Q is equal to 2.36. Okay? So now the question comes down to is, all right, what is our W? Well, W is equal to P times V. But here's the thing. What's up with the P times V? What's going on here? Well, if we look, hang on, I gotta get this back. So we have our joules here, and we need to get a little bit of information from our previous answer, because that number 2 question is depending on number 1. So there's some things we are going to need for number 1. Okay? We need to know what our work is done, right? So we said that work is equal to pressure times volume. Okay? And how do we go figure that? Well, remember, there were some things that we did, and from the problem number 1, we looked at the pressure was equal to, oh, let me rephrase that. The whole thing here, that is equal to 24 liter times atmosphere. Okay, and I believe that was from our previous problem. Yeah, see, that came from our previous problem. I wanted to make sure you guys, that 1, I was on the correct path, and 2, that you are also on the correct path. Okay? Hanging in there, Fuzzy! Jack, Dustin, Ben, wake up. I know this is a vacation for you guys, but gotta work with me here. Candy and Winry, I know they're all over it. Okay? All right. I'm joking, guys. I'm joking. All right. So we know that work is pressure times volume. Well, we got that from the previous problem, right? So the thing comes down to is, all right, well, we got 24 liter times atmosphere plus 2.36 joules. Can we add this up? Give you a moment to think. The answer is no, and the reason why, look, we got liter atmosphere and here we have joules. We can't do that. That's like adding yuan to American dollars. It doesn't work that way. You got to convert one of those currencies to the other currency. So you either convert the yuan to the dollar or the dollar to the yuan, depending. So, you know what? We're going to be converting this. How do we convert it? What's the magical conversion number for it? Well, I'll show you. He's going to tell, he's going to tell, he's going to tell, he's going to tell. Okay, so we need to multiply this times 101.3 joules for every 1 liter times atmosphere. So this is what we have to do. We have to change this, and this is how we're going to change this. Wait, where did this number come from? Right here. 1 liter atmosphere equals 101.3 joules. Boom! Okay. Let's go with it. No, I can't do this kind of stuff every day, guys. That's not possible. All right, so for us, ladies and gentlemen, we're going to go ahead, we're going to multiply this out, and we got 2431.2 joules plus 2.36 joules, and that's going to equal 2,433.56 joules. And that, ladies and gentlemen, is how we solve that answer. So let me shrink this back so you guys can see it. Okay? We needed to, remember what they gave us.